In this tutorial, we shall be creating our first orbit networks. The networks will allow us to adapt the behaviour of enemy AI in a turn-based fantasy game. As explained in the previous tutorial, designing adaptive elements in your games, we first must design the adaptive element we wish to implement. Our game is a turn-based fantasy RPG where the player and the computer take turns to attack each other. Whilst one is attacking, the other can perform actions to defend themselves. An attacker can perform fast, low damage combo attacks, slow, high damage attacks, or charge up attacks, which cause you to skip a turn but allow you to do double damage in your next turn. Attackers can also move to different attacking positions whilst taking their turn. A defender can dodge an attack by moving position, can block an attack with their shield, or, if timed correctly, parry and damage the attacker. Our goal is to design an AI agent that adapts its behaviour based on the way the user is playing. In particular, as we are making a turn-based game, we want to adapt the way the agent behaves when it's taking an attacking turn and when it's defending against the user's turn. For example, if the player is dodging a lot of attacks, we want the AI agent to frequently move between attacking positions to catch the player whilst they're dodging. If, when the player is attacking, they use a lot of slow attacks, we want the AI to parry the player before they get a chance to complete the movement. This personalization of the game experience aims to improve player engagement by creating a specific challenge to each user. The player has to figure out how to overcome the adaptive nature of the enemy to win. Let's open Unity and use Orbit to implement our design. As noted in previous tutorials, we shall create this Orbit network in our dedicated Orbit project. Firstly, we must create a new Orbit library. Our game is called Apotheosis, so let's name the library Apotheosis Orbit Library. This will open up the Library Explorer, Network Editor, and Orbit Trainer windows. If you haven't done so already, dock these windows to the editor. Let's create our Orbit networks for our game. In our game, we're interested in adapting two types of AI behaviour: the AI's attacking behaviour and its defending behaviour. As explained in the previous tutorial, designing adaptive elements in your games, we need to measure the user's behaviour to provide input to Orbit. Hence, we need two networks, one to measure the user's attacking behaviour and another to measure their defending behaviour. Let's name them Player Attacking Network and Player Defending Network. To create these two Orbit networks, focus the Library Explorer, click Add, name the network, then repeat the process once more. Highlight the Player Attacking Network in the Library Explorer. We now want to create Orbit skills to measure the performance of the user. As mentioned earlier, a player can attack by using combos, slow attacks, or charge-up attacks. Therefore, it seems logical to use free Orbit skills to measure the user's ability at each of those tasks. To define these skills, press the Create a New Skill button in the top left-hand corner of the network editor, or use the keyboard shortcut Ctrl F. Let's name the skills Combos, Slow, and Charge Up. Each time you create a skill, a box will be created in the network editor. To change the name of a skill, highlight the skill by clicking on it, then edit the Name text box in the inspector. Now that we've created all the skills for the Player Attacking Network, let's add some skills to the Player Defending Network. Highlight the Player Defending Network in the Library Explorer. This will bring up the empty network in the network editor. As explained earlier, the user has three options when defending. They can dodge, block, or parry. These are natural candidates for Orbit skills in the defending network, so let's create three Orbit skills called Dodge, Block, and Parry. We've now finished creating the orbit networks that we'll use in our game. In the next tutorial video, we'll train Orbit to adapt AI behaviour using these networks.